All right, in our last video, I talked about how to find the fundamental trig identities, and now we're going to be going through here and using them to find equivalent trigonometric expressions. So here we go. How do you verify trigonometric expressions? Well, first off, if you can, we want to rewrite the expression, the left side, to be verified that it's going to be like the right side. And one way we want to do that is we can rewrite them into terms of sine and cosine, sine and cosine. Other times, we can identify trigonometric identities and use them to simplify, or we may just use some algebraic techniques to help us figure this out. So, without further ado, let's see if we can figure this out. Well, on this right side right here, okay, we want to make sure that this tangent plus cotangent over tangent equals cosecant squared. Now, how can we do that? Well, the first thing we can do is I see this is that I would actually take this tangent and divide it into each one of these expressions. So I'm going to write it as tangent of theta over tangent of theta. Now there's other ways of doing this. I could solve it like sine and cosine, but this would be my first way of approaching this type of problem. All right. When we have this, we have 1 plus, now I have cotangent of theta. Now, if you recall, cotangent of theta, well, 1 over tangent, I have 1 over tangent here. And 1 over tangent of theta is actually the same thing as cotangent. So what we have is cotangent of theta times cotangent of theta. Well, 1 plus cotangent of theta is actually cotangent squared of theta. Well, 1 plus cotangent squared of theta, if you recall, going back, all right, 1 plus cotangent squared of theta is actually equal to cosecant squared of theta. And what we just did was we just verified what we wanted to is that this actually equals what we want. All right, so using algebra, all right, algebraic techniques, we can simplify this and putting everything else into sine and cosine. Well, let's try another one. Let's say it's sine, cosine, cosine, and sine. Now, same thing. Well, this is already written in sine, cosine, so we want to verify that this left side is equal to this right side. So how can we do this? Well, the first thing is we have two fractions. We're once again going to use some algebra techniques. Algebra techniques to help us figure this out. Well, how do we solve this using some algebra techniques? Well, one thing we can do is we can say that we want to have a common denominator. So using what we know about common denominators is I would have cosine of theta times sine of theta would be my common denominator. So to get that common denominator for sine cosine, so they multiply together, I would have to multiply both sides by sine of theta over sine of theta. Sine of theta times sine of theta is going to equal sine squared of theta, and that's going to give me cosine over sine. Right here, if I want to get cosine sine, I have to multiply top and bottom by cosine of theta. Well, cosine times cosine is cosine squared of theta. And I can combine these, and we have that. Now, if you recall, let's look to see if we have any Pythagorean identities we could use and simplify this. Well, sine squared plus cosine squared, if you recall, is the mother of all fundamental trig identities, and that equals 1. And so what we know is that that equals 1 over cosine theta sine of theta. Well, once again, rewriting this expression, we can see that 1 over cosine theta is equal to secant of theta times 1 over sine of theta, which is equal to cosecant of theta, and do a little bit of reverse and rearranging. All right, associative property. We just verified that, yes, these two are actually equal. Awesome, huh? All right. Well, we have some other ones that we can use in order to solve this, bring this out. Once again, using a lot of algebra to help us simplify these different various expressions. Okay, so from here, we're going to have, let's just try, for example, this first one. How can we verify that's going to be sine squared? Well, we have 1 plus cosine times 1 minus cosine. Well, these are binomials, all right, difference of binomials. And so what we have is we can FOIL this through. 1 times 1 is 1. And what we have is 1. We have our middle terms are going to cancel out because we have cosine of theta minus cosine of theta. And then we have our last one where we have positive cosine times negative cosine, which is going to be, all right, cosine squared of theta. These cancel out, and we're left with is 1 minus cosine squared of theta. This is the fundamental trig identity, which we know equals sine squared of theta, and we verified it. Same thing down here. 1 times 1 is 1. Middle terms, when we FOIL it, all right, distribute through, we get these cancel out. Our last these are going to be sine times sine, which is negative sine squared of theta, because this is negative times a positive. Well, we have 1 minus sine squared of theta equals, what do we know? Fundamental theorem, cosine squared of theta. Bada bing, bada boom, and that's how we have it. All right, well, once again, going through, we use some algebra, all right, in every single one of these problems to help us simplify it. We then look for a fundamental trig identity to help us identify how to get to our certain value here. Well, I hope this helps you out, and good luck and God bless in the rest of your problems.